Hello everyone. So in this video I'll be explaining RMP. What is RMP? RMP is your resting membrane potential. So basically what are the questions asked in your college exams? The questions asked will be define RMP, explain ionic basis of RMP. These are mainly the questions asked. Okay. So what is RMP? RMP is the potential of either the neuron or the skeletal muscle when it is not conducting any impulse, when it's not transmitting any impulse, उस time पे whatever is the potential difference, that will be your resting membrane potential. Now, RMP for nerve, for neuron is minus 70 millivolts, and for skeletal muscle is minus 90 millivolts. Okay, so this is the potential difference in case of a neuron, and minus 90 millivolts is the potential difference in case of a skeletal muscle. Now, what do we actually mean is, see, this is a cell, okay, suppose neuron ka. This is the ICF, right? And this will be the ECF. So, ECF ka, the reference we are taking it as 0 voltage. It's not actually aisa, but you take it as 0. So, ICF is minus 70 millivolts. So, what you are seeing is the ICF is comparatively negative compared to the ECF. So this is what minus 70 millivolts mean. Okay, mainly we'll be considering neuron wala. Okay, now the question may arise in your mind that since the name is resting membrane potential, means that the cell is at rest, so the potential should have been 0 volts, right? Then why is it minus 70 millivolts? Is because why do we need this potential difference? Because whenever we have to conduct any action potential मतलब when a stimulus आया, resting membrane में तो cell is resting, no, but जब तुमको muscle को contract वगैरह कराना है तो जब तो action potential आएगा, stimulus आएगा, so for that the cell should be electrically active. But अगर in case of resting membrane ही 0 millivolts हो जाता potential difference, मतलब अगर यहाँ पे भी 0 है तो यहाँ पे भी 0 है, if that would have been the case, तो cell इलेक्ट्रिकली डेड हो जाता एंड फिर इवन इफ एक्शन पोटेंशियल अराइव इट विल नॉट contain the impulse, so the impulse wouldn't flow if there would have been no potential difference in case of resting membrane. So resting membrane में potential difference is necessary. Now how this is minus 70 millivolts, what are the channels, कैसे generate हो रहा है, that we will see. Now what is important is resting membrane potential. So again, the cell is at equilibrium, but it is not in a steady state. See, steady state matlab there would be no flow of ions. This is the membrane, okay? So in and out there would be no flow of ions. That will be steady state. But RMP में equilibrium है, मतलब जब तक impulse नहीं आया तो constantly the voltage difference will be minus 70 millivolts. That wouldn't change, but there would be continuous flow of ions. So hence it is an equilibrium condition but not a steady condition. Now ये सब थोड़े important points है कि वो channels are open in case of resting membrane potential, because action potential के case में there are different channels opening. Resting membrane potential के case में you have to remember at least one thing कि the no voltage gated channels are open in case of resting membrane potential. In resting membrane potential, only sodium के leaky channels would be open, potassium के leaky channels would be open, and sodium potassium ADPase pump would be open. And sodium के leaky channels भी not that extensively, very little. Potassium के leaky channels very extensively. And sodium potassium ADPase pump. So which are the channels open in RMP? Sodium leaky in a bit less amount, potassium leaky are extensively active, and sodium potassium ATPase pump. Now ये एक important point था, which channels are open, and the other important point is which ion is present where. So to pay attention. Okay, I'll explain it clear. ECF and ICF, and this is the outside, this is inside. Okay, so see, ICF was minus 70 millivolts, मतलब ICF inside the cell is negative, मतलब inside क्या क्या ज़्यादा होगा, negatively charged proteins ज़्यादा होंगे, large negatively charged proteins would be more inside, and potassium is more inside, whereas on the outside sodium is more and your chloride ions are more. So if there's any difficulty in remembering कि chloride कहाँ पे है, because you might get confused कि chloride भी negative है तो यहाँ होना चाहिए था, but no, chloride. So for remembering you can remember NaCl salt, so Na जहाँ पे वहाँ पे Cl है, right? ऐसे you can remember. No voltage gated channels are open, correct? Now see, cell की कोई भी चीज़ की in this universe is a tendency. There's a tendency that they would want to go from higher potential to lower potential, or either higher concentration to lower concentration, because everyone wants to be steady in their life. Even the successful person would want कि once he has achieved whatever his aim was, कि he should be maintained at that position, but that is not the case with life, right? So everyone attempts to go in the direction of stability. Steady होना चाहता है, meaning अभी तुमको समझेगा what I was saying. See, RMP is maintained by chemical gradient या concentration gradient and electrical gradient. See, these two factors are going to maintain your resting membrane potential. क्या electrical gradient and एक है chemical या concentration gradient. So we see what is chemical या concentration gradient. That simply means that whichever ion is excess in either the ECF or the ICF, it would want to go to the other side. So see, for example, potassium is more inside, so it would want to go out. We'll consider only ions. Chloride is more outside, so it would want to come in, and sodium would want to come in, क्योंकि वो जहाँ पे ज़्यादा है उसको कम की तरफ जाना है, ताकि एक ऐसा पॉइंट आ जाए जहाँ पे the concentration of sodium in and out the cell would be same. तो steady state पे आ गया. ये हो गया तुम्हारा chemical gradient, which is the concentration gradient. What is electrical gradient? Electrical gradient means inside was negative, right? So inside negative है, outside positive है, मतलब zero है, comparatively positive है. So inside would want to become positive, outside would want to become negative. So inside is negative तो उसको positive बनना है. तो सोडियम क्या है? पॉजिटिव आयन है. इनसाइड नेगेटिव है, तो स्टेडी स्टेट में आने के लिए सोडियम अंदर आ जाना चाहिए, राइट? दैट ऑफकोर्स. क्लोराइड क्या है? नेगेटिव है. इनसाइड कंपेरेटिवली पॉजिटिव है ना, ज़ीरो. सो ज़ीरो है तो वो नेगेटिव वाला क्लोराइड यहाँ पे ही रहना चाहिए टू मेंटेन. नाउ विल बी सीइंग पोटेशियम का. सो इनसाइड इज नेगेटिव, पोटेशियम इज अ पॉजिटिव आयन. तो इलेक्ट्रिकल ग्रेडियंट के केस में पोटेशियम should stay inside. So what is happening is potassium, okay, so now we'll consider both the cases, chemical concentration gradient wala and also electrical gradient wala, and then we'll get to know the net flow. So sodium के केस में this blue वाला is showing the concentration gradient, तो influx दिखा रहा है, and electrical gradient by the red वाला is also showing influx. So sodium का influx होएगा. पोटेशियम का the chemical gradient is showing efflux, whereas the electrical gradient is showing like influx, मतलब it is showing that potassium should stay inside the cell. So क्या हो जाना चाहिए था? Cancel, but it would cancel if both the values would have been equal, if both the forces would have been equal. पर ऐसा नहीं है. पोटेशियम के केस में chemical gradient is stronger than the electrical gradient. So potassium का at the end of the day efflux ही होगा. क्लोराइड के केस में क्या हो रहा है? concentration gradient is pulling chloride inside, and जो electrical gradient है it is pulling chloride outside. So chloride के केस में you can consider as a net flow as 0. Okay, so no net flow. So what is seeing is सोडियम का इन्फ्लक्स हो रहा है, पोटेशियम का कैंसिल हो जाना चाहिए था, बट क्योंकि केमिकल ग्रेडियंट का फोर्स इज मोर, सो इफ्लक्स हो रहा है, क्लोराइड का नो. सो Now till when this flow will occur? See, potassium के channels are more, and a very important MCQ is this question is asked several times कि RMP is maintained by which ion? So it is maintained by potassium ion because potassium के leaky channels are more in number, sodium के leaky channels are very less in number. So potassium का constant efflux रहेगा, but at a certain point क्या होगा कि all the potassium from inside of the cell would reach the outside and all the sodium from outside of the cell would reach inside. So then at a certain point ऐसा कंडीशन अराइज हो जाएगा, भले ही सोडियम का स्लो हो रहा है बट एक पॉइंट आएगा कि सोडियम भी सारे इनसाइड आ गए. सो एक ऐसा पॉइंट आएगा जहाँ पे नंबर ऑफ सोडियम आयंस मतलब नंबर ऑफ पॉजिटिव चार्ज आउटसाइड एंड इनसाइड वुड बिकम सेम क्योंकि सारे सोडियम अंदर आ गए. सो प्लस प्लस सपोज +5 हो गया समझो, एंड पोटेशियम के बाहर +5 हो गया, सो पोटेंशियल डिफरेंस वुड बी 0. सो दिस शुड नॉट हैपन राइट. दैट वाज द मेन एम कि स्टेडी स्टेट में नहीं लाना है. सो स्टेडी स्टेट में नहीं आना चाहिए. So hence comes into action is a sodium potassium ATPase pump. They'll again restore the potential difference. It will pump out 3 sodium out and 2 potassium in. Why only 2 potassium? Because you have to maintain the inside of the cell negative, which is minus 70 millivolts. So hence sodium potassium ATPase pump comes into action. Now, as I already said, the question asked was RMP is similar to the equilibrium value of which ion? So it was potassium. Potassium का equilibrium potential is minus 90 millivolts and RMP is minus 70 millivolts. So it is similar to potassium. Whereas another question is asked that the RMP is equal to the value of potential of equilibrium potential of which ion? So if equal बोल दिया तो क्लोराइड है एंड सिमिलर है तो पोटेशियम है. और क्वेश्चन है बस कि मेनली पोटेशियम से मेंटेन होता है RMP बिकॉज पोटेशियम चैनल्स आर मोर राइट. दिस इज द स्टेटमेंट फ्रॉम गनोंग. द रेस्टिंग मेम्ब्रेन पोटेंशियल रिप्रेजेंट्स एन इक्विलिब्रियम सिचुएशन एट विच द ड्राइविंग फोर्स फॉर द मेम्ब्रेन permeate ions down the concentration gradient across the membrane is equal and opposite to the driving force of the ions down the electrical gradient. That's for chloride के केस में जो हो रहा है. पोटेशियम के केस में हो रहा है बट इट इज़ नॉट इक्वल.